Okay, so we are doing this chapter about traffic data collection and reduction, and we have talked about the outcome we are covering, why do we need traffic data, what is the modern purview, what are the sources, the methods of collecting the data, after you collect the data, in which applications you can apply it, what are the different traffic studies we can do, okay, and we discussed all of them. Now we move to the different methodologies of traffic data collection. Okay, so we can have manual, semi-automated, and fully automated methods. So these are the methods, not the type of studies. Type of studies we already covered in the last lecture. Okay, so this is how, not what. Okay, or why. What we are covering up to now is what and why. Okay, this is how you can collect traffic data, and there are three main types of methods. We start with the manual technique. Okay, so manual means what? Yes. Yes. Yeah. Written. Okay. So we are talking about traffic data collection. Okay, so both of you are correct. You are doing it yourself. You may have to note down the values yourself as well, but you may not have to write it every time. Noting down is the correct word, recording it yourself, but you may not be recording it on paper or on a tablet or something, but you are there and you are recording it. Okay, so you are young people, healthy, mashallah, right? So how many hours you can do it? You already done it for 15 minutes, right? So how many hours? 1 hour.
2 hours.
Huh?
3.
3 hours, sure. Okay. You want it to be more accurate with your project, right?
No.
Yes. No? Yes, 3 hours. You will not even finish the project. 15 minutes is enough. The caps are increasing. Yes. Navatra is going and the caps are increasing. Okay. So people who are thinking, you get the idea, right? That it will be difficult to do it for a long period of time. Even your cap will not save you. Okay. So manual studies are done for shorter time intervals. Okay, this is the main restriction here, that you cannot prolong it for long time intervals, and it's written here less than 24 hours. Okay, but as you can see, nobody is daring to go over even 3 hours, and that guy who's saying 3 hours will not do it for 3 hours.
Are you going to give me a bonus? Bonus?
Yes.
Give me
Yes.
how many left?
1.
1?
Yes.
Doesn't worth it.
Okay, I will do -1.
-1.
Yes. Everybody is witness, right? He said yes. Fine. She's saying yes. I see people, hyperactive. Okay. But the point was, whatever you are doing, there is a limit 4, 5, 6 hours, after which you need to change the shifts. Okay, so manual studies are often done in shifts, even if it is under the limit of 24 hours. Okay, clear? So normally 5-6 hours, and even those 5-6 hours are not straight. Okay, they have breaks in them. We will discuss them later on. Okay, but the main restriction is you need to do it for a shorter time interval. Okay, so total time will be limited, and even within that total time there will be slots. Okay, time periods. Okay, and it may not be done by one person. Okay, so if you are doing in shifts, then why can't we do it more than 24 hours? If one person is only doing it for 3 hours or 4 hours, then after that the next person comes and there are breaks as well. Okay, so why don't we prolong it for 1 week? Why this 24 hours? Okay, that has to do with the error. Okay, no matter how how many breaks you are giving and how short is the time interval, the manual technique has errors. Okay, it has more errors, okay, more random errors as compared to sensors and detectors. Okay, so every observation time has a small amount of error, maybe 1% or something like this. Okay, if you keep on prolonging it, okay, you have learned about errors in where? Which course? Surveying, huh? Which course? Statistics. Okay. So if you have 1% error in one observation, okay, and then you continue to the next observation, and it's again 1%, the total is what? 2%? Total is 2%? No. The errors don't go like this. Okay. They don't add up. Huh?
Can be added, but in square root.
Yes. Okay. So errors do not add up like 1 plus 1 plus 1. Even if you do adding up, even if you are doing adding up. Okay. So 1% error here, 1% here, 1% here, and then you can imagine if it continues, okay, then it will add up to a lot. Okay. But it's not simple addition, by the way. Errors is not simple addition. Okay. And why we are saying this? Because in the end, if I take value for 24 hours, I need value of 24 hours, right? Right or wrong? If I only need value of 1 hour, and you did it for 1 hour, and he did it for 1 hour, he did it for 1 hour, okay? So I know in 1 hour value, I have 1% error. But in the end, I will do what? I will add all the values. When I will add all the values, the errors will be also somehow added. They will increase, right? The total error will be more than the error you are getting in one observation. Got it? Clear? Yes, Sultan? Got it? Sure. Okay. So that's why we, even with shifts and breaks, we put a maximum time interval because of limiting the error. Okay, so it's not about only, nobody obviously cares about you guys. It's about the errors. Okay, we want to have accurate observation. So what types of data collection can be done manually? First two you have already done. You already done these two, right? Okay. Some of you did it using time. Okay. So these things can be done, but obviously when you are doing it when you're doing it manually, then you have to limit the time as well as the number of locations. Okay. So if you're doing it at 100 locations, you may not be able to hire, and one location will not take one guy. Okay, because each location has multiple lanes and multiple directions, multiple types of vehicles. Okay, so one location may need 5-6 people. Okay, so that means you will need a lot of workforce. So number of time is limited, the number of locations are also limited. Okay, observation studies. Okay, I called them follow-up studies or before and after studies in the last lecture. Meaning what? What is the meaning of observation studies or follow-up study or before and after study? They are the same thing, but what does it mean? Anyone? Follow-up means what? You do follow-up, right? Follow-up with the doctor, right? Follow-up means what?
You do something and then you see the effect.
Yes. Okay. So observation studies, because, for example, the projector was not working. Let's say. Okay. So somebody fixed the projector. Okay. Now when I enter and I want to check if it is working or not, I know the earlier problem exactly, right? Okay. Maybe it was not starting earlier. So I will come, I start it, starts, problem solved, right or wrong? Okay. So I know the problem and I know what should happen after. So it's a quick observation. Same thing with with traffic as well. Okay, you change signal timing. Okay, because there was a very long queue in the peak hour. Now you come there in 5 minutes after changing the signal timing. You know, because the earlier queue was going up to 500 meters. Now this queue is only 10 meters. Okay, so very quickly you can see the effect because you know what you are looking for and you know what was the earlier problem. Okay, yeah. You can make it longer and you can see the other effects as well. Maybe the Q is decreased, but maybe there's an effect on speed, but there's an effect on accidents. Okay, that will be longer studies, but that will not be observation studies. Okay, that is something else. And then we have intersection delay studies, again short duration I already mentioned, and these delay studies are also done manually. Okay, and why, we will discuss them later on. It's a complete topic, and there you will see why manual observation is important. Okay, if you are doing manual counting, then somebody mentioned we have to note it down. So we don't always note it down with pen and paper. We can note it down using these counters as well. I showed you at the start of this lecture as well. These are handheld counters, and you can use them as well. When you are using these counters, so I tell you I need a value after every 15 minutes. Okay, so even if you are writing it on the paper, you need to make some division, right? So 15 minutes ends here, and then the next 15 minutes will start, right? So either you will note it down on the paper, or either if you are doing it on the counter, I'll note down the value of 15 minutes and set the counter at 0, right? Okay, this will take some time, maybe 1 minute, 2 minutes. Okay, so you are this one or 2 minutes when you are doing these things, and these are not the only things you will need to do on the field. Okay, you may need to do, you may have to drink water. Okay, you may have to change your shifts and so on and so forth. Okay, so all this will take time. Okay, so this time has to be incorporated in a systematic way. The time which the observer needs for doing anything, personal or related to the data, okay, in which he needs a break. That break needs to be incorporated in a systematic and uniform way. We cannot leave it to the observer that whenever you are feeling tired, just go away and take a nap and come back. Okay, this is not uniform and systematic. Yeah, we tell them you can have a break, okay, but that break should be uniform and that break should be systematic. Meaning how much he will take and after what time he will take the break. That must be fixed in advance. Okay, because in the end we don't need the data which is broken. We need the full data, right? So I cannot fix the data. So the observer needs a break. That is the limitation. Okay, but the data which I need doesn't need to have the break. So I need to fix this somehow. Okay, I need to fill up the gap. I cannot fill up the gap if I don't take the break in a systematic and uniform manner. Okay, so if I don't know for how many minutes he has taken the break and when did he or she take the break, I cannot fix this. Okay, so that the breaks should be uniform and systematic. There are two methods to fix this. One is called as the alternative period, and the other one is having break within the counting period. Okay, so there is within and there is alternate. There are two methods of breaks. Okay, having breaks within and having alternate. Okay, so having break within the counting period means that you have a total counting period and some portion of this counting period is specified as break. So when he gives you the value, you know he is not giving you the value for the total period, he is giving you the value for a part of the period. For example, you tell him, give me a value for every 5 minutes. But in every 5 minutes, you have a break of 1 minute. So in the end, his value is for how many minutes? 4. Clear? This is having break within the counting period. So the break is short, the counting period is longer. Clear? Okay, and the value which you are getting is including the break. Okay, and then we have alternate break period. So you tell him the counting period, and after the counting period he has the same time for the break as well. Okay, so counting period, break, counting period, break. Okay, and the duration is same. So in the first example, if it was 5 minutes, so 5 minutes counting, 5 minutes break, 5 minutes counting, 5 minutes break. Got it? So both are equal, and the value which you are getting is without the break. The break comes after, right? So when he tells you my value for 5 minutes is this one, it is actually for 5 minutes. The break is coming after. Got it? Okay. So if I give you the value for 4 minutes and you want the value for 5 minutes, what you will do?
6 minutes.
Huh?
Make the period 6 minutes.
make the period 6 minutes, it will have 1 minute break, and now I need 6 minute count and I have 5 minutes count. So very good. This is how Einstein solved the problems of this world. Yes. You have 4 minutes of data, you will need 5 minutes. Come on, make it simple.
Extrapolation.
Huh?
Extrapolation.
Meaning what?
Divide by 4.
Divide by 4, multiply by 5. Okay? Divide by 4, it will become per minute. Multiply by whatever you need. Clear? Okay? So divide by the number of minutes he has taken the data. Okay? So if it was 12 minutes, so divide by 12. So it will become per minute. The idea is to make it unit count. And then you multiply with the number of minutes you want. Clear? Okay? Now, the other approach where it is alternative. The alternative we do what? We have one value, then a break, and then another value. Okay, so I have a value on this side, value on this side. Okay, and I need the value in the middle. What should I do?
Interpolation.
Interpolation, right? And our interpolation means what?
Taking the average.
Taking the average. Okay, but we will not say average. We will say interpolation. So people think that, see, he knows interpolation. And this happened, by the way. In a class they were saying, oh, we will do interpolation, we will do interpolation. Yeah, what we will do? We will take average. Average means interpolation. Average doesn't always mean interpolation, but yes. In this case, no problem. Because it's alternative, right? And it's the same time. So, interpolation in this case will mean average. Okay, got it? In the first case, you will convert to unit rate, multiply by the number of minutes you want. In the second case, interpolation or average. Okay? Clear? Okay. So this is an example of a highway which has 4 lanes, 2 in each direction, and we have 2 observers. Okay? We will have this discussion later on as well. You will see in some other examples mentioned that when you are doing the counting and you have number of lanes, a more accurate approach for manual counting is that you assign one observer to a lane. So the counting will become easier for him because there are no parallel crossings. Okay, and one lane means one. Okay, unless you are in Karachi where they have lots of bikes and so on. But here, controlled slightly. They are increasing, by the way, the bikes. So you will see the effects. But in one lane, it's supposed to be 1 by 1. So the counting becomes easier. Okay, more accurate as well. Parallel crossing, you have more chances of missing the count. Okay, so this is what they are doing. They have 2 observers. Okay, so they are, you can see, at a time, I have how many values? 2 values. Okay, so these 2 observers are assigned to one lane at a time. Got it? But the data is required for all lanes, and you cannot assume that they will be same, but they are not the same. 2 lanes in the same direction do not have equal amount of traffic. You know that, right? Okay, so we need some data from the other lanes as well. Okay, so what they do, they assign one observer to one direction, and he keeps on switching between the 2 lanes of that direction from one time interval to another time interval. Okay, so he is here, counting here, not here, counting here, and then counting here, and then. Okay, so at a time he is counting one lane. At a time he is counting one lane. Okay, each count is for how many minutes? 12 minutes. Okay, and then between 2 counts you have a gap of how many minutes? 3 minutes. Okay, and for each lane the count and break is alternate, right? For each lane, for one lane. Okay, for one lane the count and the break is alternate. You have the count then the break, the count and the break. Okay, so we have 2 gaps to be filled. Okay, one is these 3 minutes. There is no value, right? In any time interval, there is no value of these 3 minutes. So I need to fill this. Okay, then I have a gap which is alternate between the lanes. So I have a gap here in lane 2 and I have a gap here in lane 1 and so on. Okay, so I have to fill these gaps. Clear? The problem is clear? Okay. Okay, so first of all, we will try to fill these gaps. Okay, when I fill the first gap, which is the 3-minute gap, so the time will become from 4 to 4:15, right? Okay. Okay, I don't have a value here, but I have a value here which is 360. Okay, and I told you, you suggested what do we do? If I have 12 minutes, I want to make it 15 minutes, what do we do? Convert it to, divide by 12, convert it per minute, and then multiply by 15 because we want to convert it to 15, right? 12 plus 3, 15. Okay, so it will be 360 divided by 12 multiply by 15. How much is that?
450.
450. Okay. The next value is 350 in the other lane. How much is this? So the same ratio, right? The ratio will not change. All values are 12 minutes and all values are converted to 15 minutes. Okay, next value.
437.5.
438. Okay. 380.
475.
Sorry.
47.
475. Okay. 370.
463.
463, and the next one is also 463. Okay. 345.
431.
431. Then 340.
425.
425.
400.
400. Okay. 285.
You should use Excel.
Huh?
You should use Excel.
You should use Excel. Why should I? Huh?
Will be faster.
I don't even use Excel to
356.
check if your answers are correct. Yes.
This is for lane 2.
Which one?
This value.
Same. Lane 1, lane 2. And this will be other direction, lane 1, lane 2.
But this is for the first gap.
Huh?
This is for the first gap. We have 2 gaps.
Yeah. One step at a time. Yes. Next value.
356.
356. 310 we already did? No. 375?
No, for the lane one.
Which value? This value?
Yeah.
375? Okay. 350.
325.
325. 387. 387. 387. How much? 4? 1, 2. 340 we already have, right? 4 to 5. Okay, any problem in this one? Clear? Okay. What do we do with the values in the middle? We take average. Okay. So what do we have here? 450. What do we have here? 447. What do we have here? 416. What do we have here? 462. Here 4, 6, what? 9. And this one? Okay, this one 3, 6, 5. Okay, 3, 6, 2, 3, 3, 8. Four, 1. How much here? 4, 0, 6. Okay. Clear? Clear? We have just taken averages. Okay. Now, the first value, I cannot take an average because I am taking an average where I have the two ends. Okay. This is the interpolation we are applying, right? I have the two ends and I can take an average. Okay. But here I cannot take an average. Okay. But for example, if I had to calculate this number, okay, this number should be an average of this and this, right? Okay, this number 438 should be an average of 450 and this, let's say, x. Okay, so if 438 equals what? Yeah. 438 equals 450 plus x divided by 2, right? Okay, so x equals what? 438 multiplied by 2 minus 450.
426.
Clear? Okay. I was using the other approach, but 1 year ago a student told me you can do it like this as well. It makes more sense, right? Okay. Yes. What? 426. Same thing here. Instead of twice of 438, it will be twice of 425 minus 444. How much? This one? Right?
Yes, right.
Okay, and this one? 3, 6, 8. Sorry? My screen is same as this one. I had a friend in undergraduate, doing bachelor's, hundreds of years ago. Okay. He used to gather us in his room and we will practice together. He will take out a question and he will say, okay, this plus this answer this plus this answer this. So he will memorize everything. Okay, and he did this till the final year. This is how he graduated. He memorized all the questions. Okay. Whatever the question the examiner gave, I will write this. Okay, the examiner thinks, oh, maybe he missed the values. Okay, but he memorized everything. You guys want to give it a go? Go ahead, no problem. We will see how your examiners are. Okay, any problem up till now? It's all clear? Okay, so the 12 minutes, filling the gap with the unit count, and the other gaps using the average method. Okay, now you can see that each direction has 2 lanes. I have done the counting for each lane now. I have the full count for each lane now. Okay, so I can calculate the total of each direction and the total of the entire highway as well, right? Total of both directions as well. Okay, so the next step is, by the way, the questions are written in other slides, like slide by slide. You will see part A do this, part B do this. Okay, so we are just saving time. Okay, so for eastbound, by the way, the terminology eastbound, westbound, northbound, southbound. Okay, eastbound means going towards east. Okay, so this is going towards east, and westbound means it's going towards west. Okay, so bound is the other opposite direction where the traffic is going, not from where it is coming. Clear? Clear? Okay, and they are relative. They are relative, so it's not always the east of the compass. Okay, it's the east of that area. So it's east means my right hand side. The traffic going towards my right, I will call it eastbound. Got it? Okay, this is like the official terminology, but they adopt even in the ministry as well. Obviously, all intersections are not going east and west and north and south. Okay, but if it is going this way, and my right hand side will be east, my left hand side will be west, and so on. Clear? Okay, so the total of this one how much? How much for this? Oh, sorry. 9. 8. Okay, this one. Yes. I don't like the odd numbers. My mind blocks. So I see 3, 9, and 7. Cannot do it. Yes.
9,
9, 10.
8, 7, 5. 8, 4, 1.
8, 4, 5. This one? 8, 0, 6, right? Okay. This one?
8, 4, 1, not 8, 4, 5.
8, 4, 1. 7, 3, 4. 7, 5, 6. This one?
7, 7, 7.
7, 7, 7. This one? 7, 9, 4. 7, 8, 7. 7, 5, 6. Hmm. 6. Okay, this was for each direction, then this will be the total of both directions. Okay. Now in the question they are calling it a freeway. So freeway is the name of the highway. Okay, freeway is the name of the highway. If you go to lecture 1, you will see types of highways, and one of the type of highway is a freeway. Okay, so when they say we want the count for the freeway, that means total of both directions. Highway is both directions, right? Okay, so here they are adding the 2 directions. So this plus this. How much?
1698.
Okay.
1686.
Mm-hmm.
1703.
Yes.
One is wrong.
Sorry,
Second one is
1703.
I can't do it. Second one is what?
1656.
Okay. Next one. 1697.
1697.
Okay.
1631.
1566. Okay. 1499. Okay. Any problems? Clear?
The sum.
Yes, you will sum them. Okay, now pay attention. See, this is what will happen. You will go from here thinking that I know everything about this question. Right? This is what is in your mind right now, right? I know everything. What he is doing is very silly. Why is wasting our time? Right? And then you will look at this question after 1 month, okay, or after 2 weeks or 3 weeks, and then you will start looking for when did I take the picture, right? Even Hassan will not know where is the picture, and even if he sees the picture, he will not know what happened. Clear now? Now let's say this guy, and I don't trust him, I like him, I don't trust him,
Why?
and this,
Why you don't trust me?
I don't trust anyone. So this guy made a mistake here, he gave me a number wrong, okay? Or you should not trust me as well. Maybe he told me the right number, but I made a mistake in that. Okay? Now after 2 weeks, you will open these slides and you will see that, okay, there's a number which should be something, something, and now according to my calculations, this is the number which it should be, and this is the number I have. Okay? And you will start messaging me, and that will be the time of exam, so I will not reply, obviously. Okay? So, the point is, pay attention, try to do it yourselves. Okay? If not for the sake of you think that it's very easy, but just for the sake of making sure the numbers are correct. So at least when you look at them later on, you don't have this confusion that these 3 numbers are okay. This is an average, this is an average, this is an average. What happened to the 4th one? Yeah, 4th one was also supposed to be an average, but okay, somebody made a mistake. Okay, so try to be okay with the class. Okay, when we are calculating these values, don't think that okay, these are the numbers, I'll take a picture and everything will be downloaded in my mind automatically. It does not happen like this, especially when you look at it after 1 month. Okay. So now we have count of every direction for 15 minutes and for the freeway as well. Okay. Where is the count of the freeway? The last one. Okay. Now the next step is to calculate hourly counts. Okay, hourly counts. I will just do it for one direction. Okay, I'll just do it for one direction, and you repeat it for the other direction as well as for the last column. Okay. Now we are calculating hourly count so that we can know the peak hour. Okay, we can know the peak hour. So first of all, tell me how many hours of data I have. 2 hours of data, right? Okay, and every what is my time interval duration? 15 minutes. Okay, 1 hour has how many 15 minutes? 4 15 minutes. Okay, so if I make sets of 15 minutes, I make sets of 4 15 minutes. Each set will be 1 hour, right? Each set will be 1 hour. Okay, so this is a set, starts from 4 and ends at 5. Is this an hour? Yes. Can I make another set here? Okay, so it starts at 4:15, ends at 5:15. Is this an hour? Okay, similarly starting the set from here and reaching up till here. Okay, so how many sets I have here? 5, same as last year, right? Or the year before? The year before. Yes. Now I have a problem searching for these guys. Like, when did they take the course? Okay. So how many? 5. Okay. So I can have 5 counts of hourly. 5 hourly counts. Okay. So I will just put the count the last of the set. Okay. So the first values are 4 values are a set. 2, 3, 4. Okay. So it ends at 5. Okay. So this is not the value again. These are the things you will look at the picture and you will not get it. Okay. So value I'm writing here is for these first 4 counts. Okay. So how much is this? So you will add these 4 values. How much? Three, 6, 3, 3. Okay. Then the next one is between 900 to 910. Okay. So you will add these 4 values. How much?
3667.
Then from 925 up to 875.
364.
As I mentioned earlier, each value is a sum of 4. Okay, so don't think I did something here and took this value. No, this plus this plus this. Yes.
3558.
3558 and 3432. 3432. Okay, now I want to locate the peak hour. Okay, peak hour has minimum volume, right? Huh? Sure? Okay. Maximum, right? Okay. So which one is it? Tell me. The second one, which is what time? 4:15 to 5:15. So I know the timing of the peak hour now. Okay. And in this peak hour, how much volume I got? 3667. Clear? Okay. The next thing is we calculate the peak hour factor. Peak hour factor was peak hour volume divided by 4 times the maximum of 15 minutes. Okay. Why I'm saying maximum of 15 minutes? Because I'm using 4 here. And the counts are for 15 minutes. Okay. If the counts change, the duration of each count, if it becomes 10, okay, then this will not remain 4. Okay, it will be the maximum of 10 minutes. And I have to convert the 10 minutes into 1 hour. So this will become 6. You getting my point?
Yes.
Clear? Okay. So peak hour volume, this. This is a combination of these 4. Okay. So 3667 divided by the maximum of these four, which is yes.
0.983.
Multiplied by bracket.
See? Got it? Any problem?
Two decimals enough.
You should take pictures with me and put a nice filter on myself. No? Huh? Even if you see, what will you do? Okay. Clear or not?
Two decimals, okay.
Uh-huh.
Two decimals.
Two decimals, okay. Peak hour factor, two decimals are okay. For counts, no decimals. For speed, density, one decimal. Okay. But if you put more decimals, it's no problem. Okay. So you will do the same thing here for this direction. Okay. So you will prepare the counts of 4 sets of 4, and then you will pick the peak hour and the time and the volume and the peak hour factor, and then you will do the same thing with the last column as well. Clear? Clear? Okay. In this question, you may see that not the volume, but the other two things are matching. The time of the peak hour and the peak hour factor is matching. Peak hour factor is very normal. Okay, it's very normal that you get same peak hour factor from one direction and the other direction and the entire highway as well, because peak hour factors are normally standards for a specific type of highway. For example, if I tell you you have to design arterial in an urban area, okay, what will be the peak hour factor? Peak hour factor and peak hour time. Okay, so you can go to another arterial in the same urban area, and you can say that for this arterial, this was the peak hour and this was the peak hour factor. So it is safe and valid to take these values on my highway as well, no problem. So this is standard practice. Okay, so it's very common that you will get the timing of the peak hour same and the peak hour factor also same. It's very common. Okay, so if it comes out to be same, there's nothing to worry about, and it's very common, but it doesn't mean that it is always the same. It can be different as well. Okay. Yeah, the last step. Now each of these values, I'm talking about these values, okay? This column, this one, and this one. Each of these values is for 15 minutes, right? All these values are for 15 minutes. If we forget about this one, all these values are for 15 minutes, right? What do we call these values? A count which is taken for 15 minutes. What can I call it? Flow rate? Flow. Flow, right? Flow. And how do I make it flow rate? Convert it to 1 hour. And how do we convert it to 1 hour? Multiply by. Okay. So the last part of the question is you convert each of these values to flow rate. Okay. And you can see the answers over here. The flows are given. You may see some small difference because of decimals. Okay. I may have done rounding up or rounding down. So plus minus 1 or 2 is no problem. Okay. And for each value they are converted to flow rate. They have done it for each direction and for the not for the field. Okay, good. Any problems? Any questions? Is it clear? Okay. So the next thing which you have done as well, and that can be done easily, is the speed studies. We are still talking about manual methods, manual techniques. Okay. So another manual methodology is to do speed studies. Now, if you are doing speed studies manually, you know the most convenient method is measure the distance, have a stopwatch, let the car pass the distance, and you measure the time, right? So the speed comes as distance upon time. Okay, the most convenient method, the easiest method.
So it has a lot of error.
Uh-huh.
A a lot of error.
Yes. It's still the most convenient method, right?
Filming is
Okay.
more convenient.
Like,
Taking a video is more convenient.
sorry,
Taking a video.
you are in the same group? No? The video has some other issue. We'll talk about it. Okay. So the way you guys take videos. Some of you have done that. Okay. Some of you have taken the video properly, but like even if you be happy. Yes, you. Okay. But even for the video, taking the video, there are some requirements you have to meet. Okay. So for manual studies, you can take the short distance and note down the time. The distance is called as a trap. Okay. The length of the distance is called a trap length. Okay. So in speed studies, trap is the distance which is used for measuring the speed. Okay. And the length of the distance is called as the trap length. And another method of doing speed studies is using a direct speed measurement device like a radar, okay, or something else. Yeah. So some radars are handheld, and some radars can be put on a stand and put beside the road. Okay, like the surveying instruments you have. Okay. Now, if I'm using a device, then why am I calling it manual? It's not manual, right? If I have a radar and I take the device,
You have to write down the value.
you have to write down the value. Okay, and these devices we are talking about are manual devices. Like you have to operate the device to get the data. It's not like I will put the device and whenever the car passes, the device will record it automatically. Okay, so some of them are like this, but then they have the recording as well. Some of them are automated. So the car passes, they can take the speed. But in that case, obviously, if the speed is taken automatically, it must be stored as well. Okay, so then that will not be called as manual. Okay, so the reason why even with the device we can call it manual, because the device is operated and the values are noted down. If you don't note down the value is lost. If you don't operate the device, the value will not be taken. Okay, so whenever these two conditions are met, it's manual. Got it? So if you are doing it with a stopwatch, then you can have two types of errors. One is called the parallax error, the other one is called the random error. Okay, and random error is linked with the operation of the stopwatch, how you operate the stopwatch, how you are using the stopwatch. Okay, so what is the parallax error? Again, something which you may have heard or read in surveying. What is a parallax error? Like when you are setting up your theodolite or total station, you have to remove the parallax. You have to align it properly and you have to do something to remove the parallax. Parallax means what? Anyone? Only for her. Very good. Yes, parallax, yeah?
Setting the device horizontally.
Setting the device horizontally. Yes, one part of it. Yes.
When you're
Okay.
looking at an angle.
Mhm.
When you're looking at an angle, you can see when the car passes that point. You have to be aligned.
Yeah. So setting up the alignment of the device, basically. Okay. So the horizontal level as well, and again, then you have to align it to the staff or the rod, whatever you are using at the other end. Okay. Without that, the parallax will not be removed. Okay. So the same happens in speed measurements as well. So when you are measuring the speed, the normal setup is something like this. The circle shows the position of the observer. So you can align yourself directly with one of the points on the road. But you are doing distance upon time, right? The car is supposed to pass from you, and then at some other point you have to note down the time. When the car reaches the other point, then you will have to note down the time. Okay? So when you are looking at the other point, your line of sight is tilted, it's inclined. you can see the inclined line over here. Okay, so when I am looking at, when my line of sight is straight, I have the exact alignment of the car with the road. I'm looking straight, so the car is at this point, exact, no problem. But when my line of sight is tilted, okay, I can no longer say with confidence at what point of the road the car is on when I'm taking the time, because now like this. Okay, so this is what happens. This is called the parallax error. Okay, which is because of the tilting of your line of sight. And obviously you cannot completely control it. Okay, you can minimize it, but you cannot control it. Okay, the other one is because of the manual observation of the stopwatch. These are random errors. So when you are operating the stopwatch, you are clicking it, right? Okay, and your click may not always be in sync with the motion of the vehicle. Okay, you can be a second behind or a second forward. Okay, and you do not know about it. It's not like you are always making the same amount of error in every observation. Okay, so that's why we call it random error. Okay, because it's not following a particular pattern. Okay, I could be late now and I could be early in the next observation. I could be late by 0.5, I could be early by 1, and so on and so forth. Okay, so it will keep on going haphazardly. There's no fixed value here. Okay, so what is the thing about random errors? If I have random errors in my observation, what is the property of the random errors? Just to give you a hint, we don't consider them. We can ignore them. Why? Huh?
Very small. Very small.
Very small, could be. It could be big as well. In some cases, it could be big, yes. You are not always missing by 1 second or fraction of a second. Sometimes you can miss by 2 seconds as well. For speed, it can seconds, and then you convert it to per hour. It can make a big difference. But still, we ignore random errors because I already told you the reason. Sometimes you are early, sometimes you are behind. Okay, so when you take the final value, the average speed, they will cancel out. This is the property of the random error. They are supposed to be distributed. Okay, and the more you take observations, this distribution will become more uniform. Okay, meaning the number of values here will be similar to the number of values on the other side as well. So in the end, the average or the mean will cancel out the random error. Got it? Clear? Okay, if you have the parallax error, what do we do about it? The question is written here. I will directly go to the figure. Okay, so in this question, they have given us a case that the observer is going, or he is standing 60 feet behind the road. So the circle and the road are 60 feet from each other. From this, when he looks at the starting point, there is no problem. When he looks at the end point, his line of sight is tilted by 60 degrees. So distance was 60 feet and the line of sight is tilted by, the small delta here is tilted by 60 degrees. Okay. So when he looks at the car at this angle, okay, and he notes down the time. If you look here, he thinks the car is here because the car and the alignment of this point is same. Okay, so what he is thinking that the car covered D, distance D, but what the car actually covered because of the tilting of the line of sight, D effective. So if I want to calculate the accurate speed, I should not do this D upon time. I should do this D effective upon time. Okay, so how do I calculate D effective? Yes, so I know D1 and I know the angle. So D effective is what? Yes, D effective equals to what? If I know D1 and the angle. Huh? Very good. Could be, yes. 10, yes. Any algebraic, what? Any angle will do, okay, that involves D1 and D effective, but it will be, no, not sine, no, 10, yes. See, whenever I'm trying to encourage someone, yes, this can be true, and this is false. You guys are beyond encouragement. Okay, so my D1 is 60 for this question, okay, and the angle is 60, but you should have the idea in mind. I'm trying to calculate D effective, okay, so this is my D1 and this is my angle, okay, which are, and D1 is 60 feet and the angle is 60 degrees, only in this question. So what I'm doing is D1 10 delta. What I'm doing is D1 10 delta. D effective equals D1 10 delta. Yes.
Why use 10?
10.
10. Why use 10?
Base upon perpendicular, right? Sorry, perpendicular upon base. Perpendicular upon base. Okay, so how much is this?
$103.9.
103.9 feet, because 60 is in feet. Now if I want the speed, then it will be 103.9 upon time. The time is given as 8.3 seconds. Okay, clear? So if you want to see the effect of the position of the observer on your error, you can adjust D1, keep the angle same, and see if the error is increasing or decreasing. So you would know, as an observer, should I stay close to the road or behind the road? Get the point? Okay? Because this error is not random, it will not cancel out. Every observation will have the same amount of error, right? Every observation will have the same D effective and the difference between D and D effective. So this will not cancel out. So if you want to reduce it yourself, then you have to look at this equation and you can see how can I reduce the difference between D effective and D. And your parameters are D1 and delta. So if I increase delta, what will happen to D effective? Okay, if I decrease delta, what will happen to D effective? So you can have an idea about your position. Okay, clear? Okay, some points about speed studies which you should keep in mind. First thing is, we are looking for the most normal and average speed on the road. The speed studies are done to find out the most normal and average speed of the road. Okay, but there are people who are coming from Formula 1, right? They feel we are Vin Diesel with the hairs. So they are going very fast. Okay? Yeah. Okay. Or some of them are coming to my class. So they are out of the house, but they don't want to come, right? So they are going very slow. Okay. So they are not normal. It's not him.
Going very slow?
What?
Going very slow?
No, normal. He is normal. Don't worry about yourself. Okay. So we don't want this. Okay. So if you feel the car, but the practical reason is that for very slow cars, there could be a problem with the car. Okay. That's why he is going very slow. Okay. Or something else, which is not the case with 99% of the drivers. Okay. So including his value in the data will deviate the average towards the lower side. Because of this one or two values, these one or two values, my average can go, my average can drop by 5 to 6 kilometers per hour. Okay, just because of these one or two guys. Okay, and The same can happen with the fastest vehicle as well. They are going fast because they have health issues or they are going to hospital or something. Okay, which is not the case with the other drivers. Okay, so the normal other drivers, if the car is going very fast, faster than the others, you can ignore it. The car is going very slow, okay, and it's almost on the shoulder, you can ignore it. Okay, the first thing, because we want the normal speed. Second thing is, if there is a platoon of vehicles, we discussed in the lecture 1. Platoon, what does it mean? Platoon of vehicles. Huh? Group of vehicles which are after intersection. So in this group, again the normal trend is the front vehicles will dictate the speed. The front vehicles will dictate the speed. They will decide. Okay, until unless they go very far from the intersection. So if you see a platoon which has just crossed the intersection, so you will focus on the first front line. Okay, and the last one is heavy vehicles should be avoided. The reason is same as the first one. The heavy vehicles are slow because of their own nature, not because of the road. Okay, they are heavily loaded. They have large bodies. They have to go slow. Otherwise, they will lose control. Okay, so that's why these 3 points you have to keep in mind for your speed studies as well. Okay, try to avoid extreme values. Don't take into account heavy vehicles, and I would say if you have enough length, avoid doing it just after the intersection. Okay, but if you are doing it, then focus on the front line of the vehicles. Okay.